I would say just write down your questions and I will straight away come back once we are done with the second board of today, which is what and why behind LSA. I would expect another 15 minutes of yours. So to give a close attention on this board too. If you had any question with respect to previous board, I would say just write it down on the notepad and just raise your hands and I will do not worry, I will cover all the questions, whatever you have. So right now, just try to understand we have this simple topology. We have R1, we have R2, we have R3 over the Ethernet link, right? And this is the switch which we have. So this is the network. First IP address is given here. The second IP address is, sorry, the first IP address is also given here for this network. So the most important piece which we are going to discuss is router R1, and that is why I have defined it in a compared to R2 and R3, it is slightly bigger because this is the center of attraction in this board. What we are learning here? We are learning here what and why behind LSA, and you all know whatever we are doing. First thing first, we have understood the concept of neighborship. Why we are doing neighborship? Because as I mentioned, from the philosophy of OSPF, if these two guys are neighbors, then they are going to exchange routing information in the form of LSA, right? It is as simple as that. So what exactly this LSA? Because I have been using this term LSA from last 3 or 4 of our lectures, but I haven't defined it. So let's try to understand what link state information R1 is going to send to R2. But in this case, if we talk about the broadcast medium here, where we have 3 routers, consider the fact that we have elected a DR and DR is going to be R3. And if that is the case, then R1 is going to send LSAs to this DR. I'm not taking the BDR now. Just try to understand on this broadcast medium, everybody is sharing information with the DR and not with each other, right? So DR others are not sending information regarding these LSAs to each other. They are just sending information towards the DR. But what information they send, actually, we are going to talk about it. So if you consider R1, R1 has one network connected, right? Directly connected to it, which is 192.168.100.0. And basically on this network, we do not see any router. Maybe we have several hosts here, right? It is a network which is basically having all the hosts which want to use whatever network you are creating here. It is as simple as that. Maybe R2 is going to have such network where you are connecting the hosts, right? So this is a special type of network, right? Why special? Because it is directly connected to this R1. And just try to understand that suppose this host A wants to communicate to host B somewhere here, and the IP address of host A is suppose 192.168.100.something, which should be inside this subnet range, which is of 255 hosts. So let's consider this is the 10th host, right? The host A. It is simple. And similarly, here also we have x.x.x.x. So if a packet is going out from this network, it is going to be having the source IP address, obviously from this network itself, which is 192.168.100.10, right? And if some packet is coming into this network from here, the destination is going to be again this network, right? So when the packet comes out from this network, the source is going to be from this network. When the packet coming inside from anywhere else into this network, the destination is going to be 100.10, right? It means that this is a very interesting, I am not teaching you anything new here, but there is a pretty interesting fact about this network, that whatever the packet is going inside or coming out, whether its source is from this network or whether its destination is going to be from this network. We call subnetwork, such network, as stub network. And by the way, guys, it does not have any relation with OSPF stubby areas, right? It is just I'm talking about the network. I'm not talking about the area. So this network, whatever we have, is actually your stub network, right? Because it is not transiting. What is the meaning of transiting? The meaning of transiting is actually the packet, whatever is coming inside, is going to have the source IP address here or the destination. Means the packet is going to be end here or originate from here. It is as simple as that. But just try to understand. So just make your mind that these type of network are basically stub network. This network and this network are going to be your stub network. The second network which we see here is the network between the routers, right? So there is a network which we call 192.168.123.0/24, right? This is the network between the routers. We do not have any host here. So what type of packets are flowing over this network, which is 192.168.123.0, and try to understand this packet. Suppose a packet was generated by host x.x.x.x, and the destination was it's 100.10 somewhere here, host A, this one, right? This packet, when reaches to here, maybe it was generated by this host, it is going to reach over this R2, right? So this is the stub network from which it got generated. But try to understand, when R2 is going to forward this packet towards R1, maybe it is the next hop for this route, right? This network is only used as a intermediate network, or basically a transit network, because this IP packet does not have source or does not have even the destination from this network. And if that is the case, then basically the network between R1, R2 and R3 is just a transit network. Because the packet is not directed to this network, the packet is directed towards the other network. And this is pretty simple thing, right? If you consider, if we have these three routers connected here, and we have connected a host here, and we have connected another host here, say this is A, this is B, right? So if this is A, this is B, then basically all these links, whatever connecting between these routers, are going to be your transit. Because if A wants to communicate to B, this packet is going to flow over this link for sure. Otherwise, there is no way A can reach to B. So that this packet is going to flow from A to B over these links, but these are the transit links, right? Transit, why? Because neither the destination or the source belongs to this network, which is the link between these two routers. It is as simple as that. But why? Why we are talking about it? So in this thing, whatever we have discussed now is the concept of stub network, and the second thing is the concept of transit network. And believe me, guys, whatever I am explaining you, these are going to be very, very useful when we talk about the LSAs and when we build your complete picture from the database, right? So we just talk about stub and transit network type, right? So these are the not OSPF networks type, guys, but just generally, if we have a source and destination network inside a particular network, the source and destination of the IP packet, then basically we call that as stub. Otherwise, it is going to be into the category of transit. It is as simple as that. So let me clean the board and let me try to explain you what R1 is going to generate, right? So R1 here, if you see, R1, R2 and R3, everybody is running OSPF, and once they run OSPF, they are going to generate the LSAs, going to generate the hello message. And through hello message, R1 comes to know that it has two neighbors, R2 and R3, and basically R3 is the DR on this segment. So it is going to send, because now it is in the two-way state with R2 and R3, but as it knows that R3 is going to be my DR, so it start making adjacency with it, and it is going to send the routing information in the LSA from R1 towards R3. But what is this LSA going to contain? So we are going to talk about R1 LSA, which is right here. This orange block is something which is generated by R1, and it is the LSA generated by R1. What exactly it contains? It contains two links, right? Because R1 has only two links. So what is happening in OSPF protocol? Every router generates information about its links, right? And its links means it has only two links. One is 192.168.100.0 and the other one is this one, which is 192.168.123.0. This one is the stub link. This one is the transit link, right? If you talk about here, then that is what I have written here. Link connected to a stub network. Which link is connected to the stub network? This one, 192.168.1.0. This one, right? And the mask is here, and then basically the OSPF cost which we have configured here, which is cost 10 by default. It should be something, and that is what I have written here. Now there is another link which is connected to the transit network, which is 192.168.123.3, and interface IP address is here. So basically what I am going to talk about this. So if anybody is not seeing this diagram, if anybody is seeing only this LSA, because you can see the LSA, it is going to be like that when you want to see the LSA in the database, right? So you must be understanding that this is the LSA for router 1. It means that there must be somebody with the name R1 in the topology. Suppose you do not have any idea about this topology, suppose, right? And you are only seeing this orange information. Then whenever you see R1 LSA, you come to know about that, okay, that is fine. There is an LSA with respect to R1. It means that there is router R1 in the topology. Must be somewhere, I do not know. But you are pretty sure about it that this router is connected to a stub link where which is having 192.168.100.0, right? And the mask configured on this is 24. It is as simple as that. And the cost is 10, right? Similarly, you also come to know about it that this router is also connected to a transit network, right? I do not have much information about it, but actually on this transit network, it has found that there is a DR. So it doesn't know where the DR is, but who the DR is, it knows. And it also says that this is a transit network over which it is connected, and the IP address configured on this interface is .1, and basically the cost is 10. It is as simple as that. So where I am going from this, right? If you know the LSA, you can start building picture, right? If you do not see the topology, and even this is done by router. If I again remind you where we are with respect to our learning, we have broken down the problem of OSPF into 4 pieces. First one was the neighborship. Second one was flooding. So we are doing this neighborship here, right? And the whole sole point of this neighborship is that we can start flooding the routing information, the LSA, which we are going to discuss next, which is the process of flooding. Then basically we are going to build the database. Why we build the database? Because from the database, it is pretty easy to calculate the graph. And what is the graph? Graph is actually the picture of your topology, right? And if you have this database, which is nothing but the collection of LSAs, you can absolutely create the topology out of it. And that if you can create the topology or the graph, you can run the SPF algorithm in the 4 steps. So it is very important to understand that whatever the routing information I am sending from R1 towards my DR, it is actually the link state advertisement. I am just advertising my routes to my DR, right? And this orange network or orange piece of information is encapsulated in one of the message created by OSP protocol, which we are going to talk about in the next board. But here, basically, we are sending this information, R1 LSAs, towards the DR because we know who our DR is, right? So we are sending this information towards a DR, right here. And once DR receives this information, right, what it is going to do, it is going to collect this information or save this information into its database. Similarly, R2 is going to generate its own LSA and it is going to send it towards the DR. So what is going to happen at the DR? DR is going to contain R1 LSA and R2 LSA. What is going to be in R1 LSA? You all know about it. One network, one link which is stub connected to stub network, and another link which is connected to the network, transit network, right? Similarly, R2 is going to talk about its link and send this information. And what is going to happen next? R3 is going to send this information about its, of course, this is going to have its own LSA, right? R3 LSA is already there because this is R3. So at the end of the day, what is the duty of DR? DR is collecting the LSAs and then basically it is sending them back, right? So every router, when the DR is going to send them back the LSAs, is going to build the same table, right? Same database table where everybody is going to have R1 LSAs, R3 LSAs, and of course R2 is this router, so it is going to have its own LSA. Similarly, it is going to have its own database which contains information about R1, R2, and R3. And this is the whole sole purpose, guys, right? We need to build the common database which is exactly same, and if we can do that, then we are done. Because database forming, if we have the same kind of database across everybody, then we can run our SPF algorithm to calculate the shortest path. Having said that, now let's talk about questions. And I could see that there are 3 or 4 questions which are directly, which I could see the hand raise. Let's start with Mr. Ramesh. Mr. Ramesh, what's your question?
So, Vishnu, like in the multicasting to 224.0.0.6, where it is used, and are we still having purpose for it?
Perfect. This is a good question. Actually, so as I mentioned that we have to elect a DR, right? And suppose this is the router number 1, which is my DR. And then other routers here we have R1, R2, R3, right? Of course, there is a switch, but as I mentioned that we are going to have adjacencies between these guys. So when this guy creates its LSA or LSA update message, we haven't studied about update message. These are generated by OSPF protocol, which works at layer 3. This is going to be encapsulated in the IP. We should have source IP and destination IP defined here. So source IP is going to be whatever we have here, right? Suppose this IP address is .1, and here comes the destination IP. Generally, we send all this information hello on the multicast address of 224.0.0.5. We send the hello packets here. It is as simple as that, right? We have sent the hello packet here, but now if I send the hello packet here, then or the LSA here, then every other router is going to listen, because if we run OSPF on all these routers, then it is listening at 224.0.0.5. As I mentioned previously, that whenever you run OSPF, every router in OSPF is going to listen on this multicast address. It is as simple as that. And that is what I don't want, that these routers should take, means if R1 send the LSA, it is of course going to reach here, right? Because this is a broadcast medium, and generally switch consider multicast as a broadcast. But what I want is that these routers should ignore these LSAs. Only the router which is actually responsible of distributing these LSAs should listen to them. So as we all know that every router is going to be listening at 0.5 multicast address, including this guy. It is not, although it is a DR, but at the end of the day, it is running OSPF. So it is listening on 224.0.0.5, but I have made it special. I have asked this DR, okay, you are listening at 0.0.0.5, that is, sorry, 224.0.0.5, that is fine. Start also listening on 224.0.0.6. This is the address, multicast address of my DR. So this LSA, which you are going to encapsulate in the IP, the destination IP is going to be your 224.0.0.6, right? This IP packet is going to be reached to R2. R2 is going to see, okay, it is for 224.0.0.6. I am not listening on this, and that is why I'm just going to discard it, right? Similarly here. But you must be thinking that if the flooding is happening this way, then what is the purpose? The purpose is, see, this switch which we have here, right now we are considering it as this is not multicast aware. If it see a multicast packet, it is going to broadcast. But if you make this switch as a multicast aware, then basically this LSA is going to be here, but it is going to be delivered to DR only, because DR is listening on 224.0.0.6 and nobody else. So this packet is not going to be forwarded towards R2. R2 is never ever going to reach it. But in this situation, even R2 and R3 gets this packet, they are not going to entertain it. And the reason is they are not listening on 224.0.0.6. It is as simple as that. Okay. Mr. Ramesh, did I answer your question?
Yeah, Vishnu. Thank you.
Perfect. Mr. Supreet, what is your question, please?
Yeah, Vishnu. So can you just move to the diagram which you showed right now?
The DRBDR or this one?
Yeah, DRBDR. So I had 2 to 3 questions related to this. So
here, right?
No, the second screen itself.
Oh, okay. So this is basically the LSA board, right? You have question on LSA.
Okay, yes. Yeah. I'm sorry. Yeah. So how did R1 come to know that R3 is my DR? So I must have missed that point, but just need to make sure. How did R1 come to know that my R3 is the DR and I need to send the LSA to DR itself?
Yeah, this is interesting. So just before this, I have explained the board where we were talking about DR and BDR, the election process. In this board, I have just presuming that over this link, the DR election has happened. And once the DR election has happened, the hellos which are coming, right, which I mentioned here, if I showcase you here, that this is the starting stage where every router is sending the hello, but inside this hello, I'm writing with the green pen, they are writing designated router at 0.0.0. But here at the next board, I have started. So just try to understand, in the next board, I have in this board, I have showcased you the way how you are going to find the DR, right? If you find the DR, which is right here, any LSA which is going to be generated even with the R1 from the R2, they are going to say that over this network, they have selected a DR which is R3. So in the designated router field, it is not going to be 0.0.0 this time. It is going to be 3.3.3.3. So this is, suppose you do not have any DR here and everybody is freshly booting up, right? If everybody is freshly booting up, then what is going to happen? Nobody knows about DR, right? So everybody is sending hello with all zeros in DR field. Then R1 start electing it, R2 starts selecting, and everybody is going to be on the same page. Why? Because they are receiving the same hellos. R1 is going to receive the hello from R2, it is going to receive the hello from R3. R2 and R3 are going to be the priority, including the priority value, which is going to be 1 by default. The next, and this is tie, and that is why the next thing is going to happen as a router ID level. Router ID of R3 is greater than everybody. So R3 is going to be selected as a BDR first, and then it moves to the DR, right? So everybody knows, everybody start calculating on it there that R3 is my DR. And now once they have elected, they are going to include this information into the hello messages. Instead of writing 0.0.0 in the DR field, they are going to write 3.3.3.3. I'm not talking about BDR. I do not want to make it complex, but yes, DR election is already done here. R1 already know about it, and that is why it is sending this information, LSA information, to R3 only. Okay, Supreet?
Yeah. So my second question is, so the DRB header is per LAN segment, right?
Yeah, absolutely. Just try to understand the reason behind it. I could see this statement from a lot of people that it is on the LAN segment. Absolutely, it is. Suppose you have these three routers connected, R1, R2, R3 over a switch, right? This is here. But if you have R4 here, and this is the WAN link, which is point to point, then of course we have a DR-BDR election here because we want to improvise. We want to increase the efficiency of OSPF flooding process. That is why we are selecting here DR, but here not. But try to understand, if this link is not point-to-point link, right? Suppose I have another router R5 and this link is not point-to-point link. This is again the Ethernet link, but you can see that we are having only two routers here. Still, because this is the Ethernet, we are going to select the DR-BDR here. So per Ethernet link, you can say per broadcast network, we are going to choose DR and BDR. If we are running HDLC here, it is a protocol which is by default point-to-point. So OSPF is going to run point-to-point network type here, and there is not going to be DR and BDR. But here we have, and here also we have. So did you get the point, Supreet?
Yeah, got it. Yeah.
Perfect.
Thank you.
Perfect. Now let's ask what is in your mind, Mr. Ramesh? What didn't you get? Yeah. Ramesh, can you hear us?
Yeah, Vishnu, is it for me?
Yeah. Are you asking any question? Ramesh?
No, you already answered, right? I was asking about 224.0.0.6.
Oh,
It's been already
actually your hand is still raised, so I thought to ask you again.
Oh, I'm sorry. Yeah.
No problem. Let's talk about Mr. Kamal. Can you please ask your question now?
On which state DR-BDR election happened?
As I mentioned, that previously, as soon as we meet the two-way state, right?
Mm-hmm.
Two-way is nothing, but we know that R1, if we talk about R1 and R2 knows about me, and that is why I am saying hello in this message. So R1 knows that there is somebody called R2, and he knows me. R2 knows that there is somebody called R1, and he knows me. Then they are basically two-way state. And if they find that they are on the broadcast medium, then they immediately start making the process of OSPF efficient. And that is why they are going to select the DR-BDR immediately after the two-way state. We haven't discussed the next stages which happens in the neighborship, which we are going to. But your question, the answer is that DR-BDR election just happened after the two-way state. When a router knows that we have these neighbors, now I need to select a DR if I am on the broadcast network. Okay?
Okay.
Perfect.
So after the two-way and before the XR state, you mean to say?
Yeah. The next thing, see, the whole sole point of having any neighborship is to exchange LSAs. I haven't talked about how we are going to exchange LSA. But first thing first, at least has the adjacency, because on the broadcast network, a neighbor should be adjacent, and once it is adjacent, then we are going to send LSAs. And if we want to send LSAs, then basically your next stages comes into picture, which are extract, exchange, loading, and full, which we are going to discuss. But your understanding is absolutely correct. But just try to understand why. You do not need to remember it. It should be with you always. Okay?
Okay.
So, Kamal, I have answered. Mr. Balakrishna, please do ask your question.
Yes, Vishnu. So you are telling about the switch should be aware of multicasting, right? So it is of L2 switch or L3 switch?
It is L2 switch, but you can make it multicast aware by running few protocols on it. One is proprietary, which is CGMP, Cisco Group Management Protocol, and the other one is RGMP, which is Router Group Management Protocol. So if you run these protocols, and basically this is a whole different topic to discuss. But yes, you can make this switch multicast aware, a layer 2 switch.
Layer 2 switch. And then you are talking about that per Ethernet segment we are running this, right? Transit network, right? Point-to-point link. If we are using a point-to-point link between two routers as Ethernet, okay, we can force that link to behave like a point-to-point, right?
Yeah.
Link type point-to-point
Yeah.
can be mentioned.
Yeah. And if we do that, then basically we do not need a DR-BDR election there. Yeah.
Okay.
If you just
So
just change the OSPF network type from the broadcast to point, you are not going to see the DR-BDR election.